Hi everybody, I am Mayet Sakulingan, and in this short video, I want to share an idea for bringing environmental and sustainability education into a math or grade 11 functions class using trig functions as the mathematical part to explore wind energy. This is on the environmental and sustainability education part. So the specific expectation will focus on modeling and solving problems involving periodic phenomena with the use of sine and cosine functions. So for this one, I will start the class with maybe a short video clip, or it can also be an image of a wind turbine spinning, and will then ask the students what they observed about how the blades moved. uh, you know, Common answers or answers may be, that the blades rotate in a smooth, repeating motion, which I will then use to link to the mathematics or trigonometry, where I will say, yeah, this is a perfect example of a periodic function. And then we'll ask the whole class if we can use trig functions to model the motion or that motion. But before we do this activity in class, the basic topics for trigonometry, like the sine cosine, the trig ratio, the graphs of sine and cosine functions, and even the transformation of the trig function should already be covered. So it will also be easier for the students to understand, or link wind turbine and the graphs of wind turbine to the trig function that they will see in the next slide. So this one here is the function that they are going to observe in using Desmos. So I will introduce a basic model of circular motion using a sine or say cosine function. So here in this function, which is a cosine function, where A represents the radius of the blade, B is, the speed of rotation, and of course the D is the vertical translation of the graph. Now, with this one, they will play around, the graph, and we also used this part of the activity to review the prior learning topics or the previous topics that were already covered in class. So this will be in Desmos. So the students will see how a simple cosine function can describe a real world energy system. And then here in the next part would be to the application part, the energy and sustainability part. So um, I will connect, the that function into renewable energy. So we will talk briefly about how wind turbines would work and why they are important in reducing fossil fuel use. And I know of this application that we used in my previous class, where a previous class at the University of Toronto, where we use merge cube. So in that merge cube, one of the applications that we can use for animation is about wind turbines. So the animation will show, or the simulation will show the process of converting from wind to energy. So here I will ask the students what are some of the benefits of wind energy and what are the challenges. We will also discuss where wind farms are located and how understanding the math behind will help engineers optimize blade design and the speed for better energy output. And then, as an outdoor or hands-on activity, In class, maybe students will create their own trig models with wind turbine blades. They can adjust the amplitude, the frequency, the vertical shift. They can use Desmos to do that. And will then answer the questions like how does changing the blade length affect the graph, or what does a faster rotation would look like. Another that can also uh, be assigned to the students is to compare wind energy used, say in two countries, and they will model how many turbines would be needed to power, say, for example, a school or a community. And then, in terms of assessment, that last one can be used in assessment, or it can also be just, a short quiz on matching trig functions to turbine motion graphs. A short project where students will design a wind turbine setup and will explain how, trigonometric modeling helps improve the efficiency of the output. And in terms of, yeah, so final thoughts on this one. You know, with this requirement in our class, it helped me as a math teacher understand that I can um, make use of these different energy and sustainability topics in mathematics. So um, I have more options or more uh, ways on how I can link real world scenarios into math. In terms on the student side, providing or giving this activity to the students, this type of activity to the student will help them see that math isn't just about numbers. It's also about understanding, systems, movement, and even how clean energy is generated. So by tying trig functions to wind turbines, um, mathematics is more relevant, more visual, and more connected to what is, what's happening, in the community, or what's real. So yeah, so the activity really helped me, as a math teacher to think outside the box instead of just using the usual way of assessing the students if they understand or if they have a good understanding of the mathematics. So this way, um, linking it to environmental and sustainability education would, not only provide opportunity for the students to show what they understand, but at the same time, um, uh, let them see or make them see the importance of math, and also the importance of the uh, environmental and sustainability topics into the class. That would be all. Thank you very much for listening.